Talk function notation. So at this point, whenever we've written y is equal to mx plus c, we write it like this. But there's actually a really cool way we can write it instead. And you roll your eyes at me and you say, so it can't be cool. We're doing function notation. And I tell you, it is actually really powerful what we can do with it. We can write instead f of x is equal to mx plus c. And what does that do differently? Well, f now becomes this thing. It is a function. What is a function? Well, a function takes an input and does something to it to create an output. So you can think of an x as being some input, f being some kind of machine, and f of x being the output of that machine. For example, you could have a machine which doubles. So its job is to times by 2. So it's a doubler. So you put in 3, and what comes out to the other side is 6. It's a doubler. Instead, all we do is we encode that as a function. So we can say that f of 3 is equal to 6, or more broadly, right, if I have x, when I put x into the f, what do I get? I get 2x. Because what is it doing? It's doubling it. So I can say that f of x is equal to 2x. The function's job is to take an input x and double it. But I could make any sort of input, or any sort of function. It's just a really powerful notation, and you'll see as we go further along in this course why function notation is so powerful. So let's have a look at a function called f of x is equal to 3x minus 7. So let's do some stuff with it. Figure out what is f of 4. Well, f of 4 literally means, instead of x, 4. So f of 4 is equal to 3 times 4 minus 7, which is 12 minus 7, which is 5. So f of 4 is equal to 5. So it's a way of substituting in a value without having to write x equals 4. If we were doing this using standard notation, we'd do y is equal to 3x minus 7, sub x equals 4, y is equal to 3 times 4 minus 7, y is equal to 5. And you can just see how much simpler it is to just say straight from f of x to f of 4. What am I doing? I'm substituting in 4. But we can also do it backwards. So I could ask instead a different question. When is f of x equal to 7? Well, that's basically a y substitution. So replace f of x with 7 into the original equation equals 3x minus 7, and we're solving for x. Let's add 7 to both sides to get rid of the 7 on the right hand side. We get 14 is equal to 3x, and we can divide both sides by 3. 14 divided by 3 is 4, remainder 2 if you want, or 4.67, or I prefer 14 over 3 if I'm honest. And so x would be equal to 14 over 3 when f of x is equal to 7. Alternatively, we can write it as f of 14 on 3 is equal to 7. So it's a really powerful notation, and it's going to come up all the time. So we're going to have a little bit of practice before we move on. See you in the next one. Goodbye.